Welcome back, everyone. Now that we understand how to extract feature information in numeric form from string text data, let's now show you the process of performing a classification supervised learning task with text data. So in part one, we're just going to do a very simple data analysis and then also perform any feature vectorization needed. Let's head to a notebook. Okay, here I am in the notebook. I'm going to import pandas as PD, and I will also import Seaborn as SNS and import Matplotlib.pyplot as PLT. So the data file we're going to be working with is called airlinetweets.csv. So underneath the data folder, there's a file called airlinetweets.csv, and if we take a look at it, you can check out the lecture notebook for full information on where it's from and details, but it's a pretty simple file. It has a tweet ID, a unique identifier, the labeled airline sentiment, which means someone has read these tweets and labeled them either neutral, positive, or negative. So those are the three label categories, and we'll confirm that later on. And then if you keep scrolling over here, you'll see some other features. So it's the confidence level. So that person also gave their rating a confidence level, and it's a negative confidence level, so keep that in mind. And then they also provided a negative reason if they saw one out of a group of categories. So whether it was a bad flight, can't tell, or if it just was left empty. Then there's also the confidence for that negative reason. And then there's the airline that particular flight happened on. And then if we keep scrolling over here, you'll notice there's usernames and more data. So name, there's also a negative reason gold, which is a feature we won't need to worry about. And then there's retweet count, and most importantly, there is the text information. So really what we're concerned with here is, can we take this text information and the already known label, so scrolling over here again, whether it's negative, neutral, and positive, and create a classification model that takes in a raw text string tweet and reports back if it thinks that tweet was neutral, positive, or negative. That way, we could have this machine learning algorithm just automatically read Twitter for us and then let maybe our customer support service know that they should reach out to that particular person if the tweet is negative. That way, we don't need actual humans reading thousands and thousands of tweets. So let's do a little bit of data analysis, some exploratory data analysis on this. We're going to start off with a count plot. So we're going to say SNS count plot, and let's just check out the airline sentiment data. So we'll say the data is DF, and the main column we're concerned with is airline underscore sentiment. This is our Y label we're going to be trying to predict, and the three options here are neutral, positive, and negative. So the vast majority of the tweets are negative. And when we're thinking about it in the context of what problem we're trying to solve, really what we care about is trying to perform what's more like a binary classification task than a multi-class classification task. What we want to do is be able to find negative tweets and separate them out from neutral or positive sentiments. It's not a big deal if our model confuses neutral with positive tweets, because we're not going to send a customer support agent to someone that's tweeting something that's neutral or positive. We really want to be able to catch the negative tweets. Now, this is for the particular kind of painted situation we're giving here, but keep in mind in the real world, maybe you do want customer service to reach out to people that have positive tweets in order to maybe reward them for their positive tweet or just commend them, etc. So keep in mind, for our particular situation, we really care about negative versus everything else. So one tactic to kind of combat this would be to actually transform neutral and positive into a single class called other, and then you would classify negative versus other. But for our use case, we'll just keep them as three separate categories, but when we're viewing the confusion matrix, we'll keep in mind that we really care about finding those negative tweets. The next plot we can check out are the negative reasons that people were able to figure out on why they were reporting a negative tweet. So for the negative tweets, some of them actually have that negative reason column that we saw. So I can create an SNS count plot, say data is equal to DF, and X is equal to, and the column is called negative reason, all one long string. Run that, and you can see for the tweets that did have a negative reason associated with them, we have this count plot, but let's go ahead and rotate those X ticks. So we're going to say PLT X ticks, and we'll say rotation is equal to 90. run that, and we can add a semicolon here. We don't want to see that. Perfect. And we can see that the most popular reason that somebody associated the negative tweet was with a customer service issue. The other ones were late flight, maybe not much we can do depending on whether it's a mechanical issue or an airport issue or a bad flight. A lot of people couldn't tell, but really it's not good that we have a customer service issue as the main reason for these negative tweets, especially if we're thinking about this from an airline customer service perspective. The other thing we can do is compare airlines with each other. So you notice there is an airline column, so these don't all belong to the same airline. They're not all Virgin America. We can scroll down here and do the following. Say SNS.countPlot. Data is equal to DF, and then X is equal to the actual airline, and then we can color the hue by airline sentiment. So airline underscore sentiment. Go ahead and run that. And if you want, you can sharpen this up a bit with some Matplotlib. But really, we're just trying to compare what are the issues. And you'll notice for Virgin America, they're actually doing quite well. They have about as many neutral and positive tweets as they have negative tweets. United and US Airways and American are kind of the worst offenders here, with way more negative tweets than there are positive and positive and neutral. And then Southwest and Delta, a little more even, again, more negative tweets versus the other ones. But Virgin America, ratio-wise, actually performing better. They have more positive and neutral tweets than they do have negative. And obviously, the United Airlines can't say that. Now, let's go ahead and start setting up our data in order to analyze it with a machine learning model. So for this, what we can do is start separating out the features and the label. And for this particular case, we're going to really focus on just the raw text versus the airline sentiment. So we're going to grab two columns here. One is the airline sentiment column. So we'll say underscore airline sentiment, and then the next one's going to be the text column. So we'll call this our data, and it's just airline sentiment and then the text of that actual tweet. And now let's also separate this out into an X feature set. So we're going to say our X features is equal to the actual text. And if you want, you can do this off DF or data. And then Y is equal to data and then the airline sentiment. Whoops, there we go. So do we need to actually separate this out, data from DF? Not really, but it's kind of nice to just be able to view exactly what we're working with here, which is just two columns, airline sentiment and the text column. So we're going to continue along, and what we're first going to do is a train test split before we perform vectorization to avoid data leakage from the fit transform calls. So to do this, we're going to say from scikit-learn.model_selection import train test split. Then we'll go ahead and call it train test split, expand on this here, and we're going to scroll down until we're able to find here what we're looking for. So we're looking for that tuple unpacking. Going to grab it, copy and paste it here. And let's go ahead and change this so we're dealing with a 20% test size and a random state of 101. You can go ahead and mess around with those values if you want. And now it's time for vectorization. Recall from the previous lecture, we can directly use 𝑇F-IDF vectorizer to do this all in one very clean, simple step. We say from sklearn feature extraction dot text import 𝑇F-IDF vectorizer. And what's really important about 𝑇F-IDF vectorizer, when it comes to a bunch of documents that are kind of around the same topic, such as airlines, we want to make sure that we're able to take into account how often certain words appear throughout all the documents. And that's important for things like planes or flights, since those may not be actually indicative of whether the tweet is positive or negative, because you're going to end up using the word flight maybe on a great flight or a horrible flight. So maybe the word flight itself, if it appears in many of the actual text, that is these documents, is not going to be super useful, which is why I want to take into account that term frequency and the inverse document frequency. All right, so moving along here, let's create our 𝑇F-IDF vectorizer. We're going to say 𝑇F-IDF, create the vectorizer, and then what I'm going to do here is say stop words, and we're also going to remove English stop words. Okay, then let's set up our X train. So we're going to say 𝑇F-IDF, and I'm going to fit it to xtrain. This is kind of the same process we've done with scaling our data, where then I only fit to the training set, but then I'm going to transform xtrain. So recall xtrain right now is still the raw text strings. So now what I'm going to have is xtrain 𝒕𝒓_IDF is equal to the transformation here. And we'll do the exact same thing, except now it's going to be for xtest. So we'll say 𝒕𝒓_IDF, transform, and just like we did with scaling, notice here I'm just transforming and I'm not fitting on xtest. Okay, so that is the vectorization process. Again, I imported 𝒕𝒓_IDF vectorizer, removed the stop words, then I fit just to my training data, and then transform xtrain and xtest into the 𝒕𝒓_IDF versions. So if you actually grab these to check them out, you'll notice they should be now sparse matrices, which is nice because scikit-learn can actually deal with these. Do not transform this into .2dense because these are much, much larger than what we were dealing with before. Okay, so coming up in part 2, we're going to begin working by comparing actual models. We'll work with naive Bayes, logistic regression, linear support vector classifier, and see how they compare against each other. I'll see you at the next lecture.